Hello everyone, welcome back to the channel. Today we are going to diving with the topic what is a Gaussian or normal distribution in statistics. This is the most important like the terms because it helps you to understand the distribution of the data. So stay with me till the end of the video if you want to learn about the Gaussian or normal distribution in detail. So let me open my whiteboard. Before moving ahead, you should be aware with following terms which is important regarding the formula to calculate the distribution of the data in random or Gaussian distribution. So this is your random variable. Okay. So random variable can be any X variable. It can be integer, string, float. Okay. Like in Python, you declare like this, X is equals to 10, 2.5, or maybe it can be string. Right? So it is of a two type, continuous and discrete. So continuous, we will take a very good example again, house sale price. So house sale price is between the range of 200K to 600K, but there are some values lie in the float too, in between. Okay, so this is called the continuous number. It contains float numbers too and integer too. But it is within the range, but it contains the float numbers, decimal number too. But if we take an example of discrete, let's say you want to calculate the total cars in different parking lot parked, right? So this is, we can say, total cars in parking lot. Okay, it can be 10, 15, 20, 25, 40. You cannot tell me like there is a 10.5 cars, right? It always be the single whole number. This is called discrete. It will be within the range or in the grouping form, but we are all interested in the whole number. At that time, we declare this. Okay, so this is the discrete. Here, the next one is if you want to find out the normal distribution, Gaussian distribution of your X, you will need to calculate the mean and standard deviation too. If you don't know what is mu, this is the average, mean. We denote it with the mu. If you want to take out the average of this one, you will simply apply the formula summation of xi divided by total number of your data points. So it is going to be 10 plus 15 plus and so on. What is the total number? 3, 2, 5. 5. Let's say its average value come up 12. Okay. And now if you want to find out the standard deviation, this is the one you need to first calculate the variance. So what is variance? Variance formula is this one. Xi minus mu square of this. Then it is going to be 10 minus 12 square, 15 minus 12 square, and so on. Again divided by total number. Let's say its output is 9. Okay. Now how would you calculate the standard deviation? So this is your standard deviation. We denote it with the sigma. This is going to be equal to square root of variance. Square root of variance. It is going to be 9 and your standard deviation value is 3. Now what is this? Let's say this is your data points here. This is your X. This is the mean. Okay. So now your standard deviation will come here. This one. So this is the 3 and minus 3. So this means you have some x of x value at this point. Okay. You have some data points which is far away from your mean on this your distribution. This is a distribution. Okay. So or in other way you can say this is a range. The data points lie between from your minus 3 to 3. Okay, because this is going to be the square root value of this one. This is going to be your first standard deviation. Okay, now I will draw this diagram again and I will show you, because now we are going to continue with the definition of your Gaussian theorem. But these terms were important, like what you should know before calculating the distribution of the data of your given random variable. So we will clean this up. Now I will draw the diagram of your Gaussian distribution. This is the one. Okay. So this is your Gaussian or normal distribution. How? Because the mean lie in the center. Okay. Now we will calculate the empirical, using empirical formula, the probability of your X data points lie within some range away from your mean. Empirical formula. Okay. So I will tell you here, this is the first standard deviation, 1. This is the your from this range. So your first standard deviation lie between the -1 to 1. This is again away from this one. Okay. This is your second standard deviation. This is your third standard deviation, -2, and this is -3. Okay. We also call it 3 sigma points as well. 3 sigma standard deviation, because it has the 3 ranges. Okay. Now we will calculate the formula, empirical formula, the distribution of the data. So what was the formula? We were doing like this, right? Gaussian theorem of mu and sigma. So the probability of your finding the first standard deviation will be this: mu minus standard deviation less than equal to your X data point. What is X? This is any data point of your X random variable, right? Less than equal to mu plus sigma. It is going to cover up your 68% of the data distribution. This means this is going to be 68% of your total data points, the data. Okay. So how it will look like? -1, this is covering up from left to right. -1 to +1 standard deviation. This is the range of your this one. Okay, the small x. It is covering up your 68% of your this one. 68% of your total data points. It can be x. This is a random variable. Okay. The next probability of your is -2 sigma less than equal to this one, mu 2 sigma. It is going to cover up your 95% distribution of your this one. Okay. 95% of your this variable. So what will be the range? How far away from the mean? This one, right? So the total standard deviation from -2 to +2. It is going to cover up your 95% of the data. Now probability of finding the next third standard deviation is between this range. 3, this one. It is going to cover up your 99.7%. So this is your this range. This is going to be 99.7. So this is within the range. So this is the way how we calculate the distribution of the data, and this is in your data is in the normal form. Using the empirical formula, you can calculate the range of the data, how far away it exists from the mean to. Okay. And this is creating the bell curve shape. This is, we call it bell curve shape. Okay. There is a no skewness, mean is in the center. So this is called normal distribution. So this is a way how you can calculate. And this was all about the definition of your Gaussian or normal distribution, your formula in the statistics. I hope it makes a sense to you. If you are new to my channel, please don't forget to subscribe my channel. Share with your friends who want to learn about the statistics, this part, Gaussian and normal distribution. Thank you so much for watching.